Finding the maximum average subarray looks like it needs a naive approach, but there's a sliding window trick that makes it much more efficient. The problem requires us to find the maximum average of a subarray of a given size within a larger array. For example, given the array 1, 12, minus 5, minus 6, 50, 3, and a subarray size of 4, we need to find the maximum average of all possible subarrays of size 4. This involves calculating the sum of each subarray and then dividing by the subarray size to get the average. The brute force approach involves iterating over the array and calculating the sum of each possible subarray of the given size, which results in a time complexity of O, n asterisk k, and a space complexity of big O of 1, constant time. However, this approach is too slow for larger arrays and can be optimized using a more efficient technique. The key insight here is that we can use a sliding window to efficiently calculate the sum of each subarray. We start by calculating the sum of the first subarray, and then we slide the window to the right by subtracting the leftmost element and adding the next element to the right. This way, we can calculate the sum of each subarray in constant time. You'll recognize this pattern when you need to find a maximum or minimum value within a subarray of a given size, and you can apply the sliding window technique to solve it efficiently. The time complexity of this optimized solution is big O of n, and the space complexity is big O of 1 constant time, making it much more efficient than the brute force approach. Now that you've learned how to solve the maximum average subarray I problem using the sliding window technique, try applying this pattern to other array-related problems, such as the minimum window substring problem. Don't forget to subscribe and ask questions in the comments.